All right, guys. Today we're going to start on Chapter 8, Section 7, Complex Numbers. And today we're going to talk about these two sections here. We're going to talk about Section 1, simplifying numbers of the form square root of negative b, where b is greater than 0. And we're going to recognize complex numbers. All right, so first thing we want to do is simplify numbers of the form square root of negative b, where b is greater than 1. So the imaginary unit I is defined as I is equal to the square root of negative 1, where I squared is equal to negative 1. Okay, so I is the principal square root of negative 1. So what this allows us to do is to find any positive real number, so that when we have a negative value under the radical sign, basically this allows us to solve for it. So write each number as a product of the real number and I. So we know that we can break this into two parts, the square root of negative 25, and that's going to be equal to the square root of negative 1 times the square root of 25. So it's I times the square root of 25, so we would end up with 5I. Now we have negative square root, or negative square root of negative 81. So again, you're going to end up with negative I, and then the square root of negative, or square root of 81 is 9. So this would be negative 9I. In part C here, 7 is prime, so we cannot take there's no square root of 7, that's not radical. So we end up with I times the square root of 7. And then in part D here, we'll look at this as negative, or square root of negative 44. Well, that's equal to the I times the square root of 44. Well, the square root of 44 is the square root of 4 times the square root of 11, which becomes 2I square root of 11. So it's easy to mistake the square root of 2I for the, or 2 times the square root of, square root of 2 times I, for square root of 2I with the I under the radical. So for this reason, the I goes in front of the square root. So it's I square root of 2, as in the definition of square root of negative b. So the next part here we're going to do is we're going to do some little bit of multiplication. So the square root of negative 6 times the square root of negative 5. Now, we end up with I square root of 6 times I square root of 5. Now, remember, I squared is equal to negative 1. So we get I squared times square root of 6 times 5. So this would be negative 1 times 30. Okay. All right, so just negative square root of 30 there. Again, square root comes out. I square root of 8 times I square root of 6. I squared 8 times 6, which is I squared times the square, I squared square root of 48, which is 16, I squared 16 times, square root of 16 times 3, which is negative 4 square root of 3. Okay, over here, this is I, right? So we have just, this is the negative, so we're just going to have 1I, square root of 5 times square root of 7, and this becomes I square root of 35. All right, let's look at dividing some of these out. So we have got the square root of negative 80 over the square root of negative 5. So we're going to get those i's out. And we can go ahead and cancel those i's. So now you end up with the square root of 80 over 5, which is equal to the square root of 16, which is 4. Over here again, we have I outside of the square root, right? We had the square root of negative 40, so we get I out of there. This becomes 40 over 10, which is I square root of 4, which is 2I. Okay, so recognizing complex numbers. If A and B are real numbers, then any number of the form A plus BI is called a complex number. In the complex number A plus BI, the number A is called the real part, the real number, and the number B is called the imaginary part, the part with B. Okay. So for a complex number A plus BI, if B is equal to 0, then A plus BI is A, which is a real number. Okay, so the set of real numbers is therefore a subset of the set of complex numbers. Okay, so this is a new set of numbers that we are dealing with here. And the set of real numbers, if we take a look at a Venn diagram, so if you had before all real numbers, well, those are a subset of complex numbers. Okay. Oops, I'm going to erase that. And if A is equal to 0 and B is not equal to 0, the complex number is said to be a pure imaginary number. Okay. So for example, 3i is a pure imaginary number. A number such as 7 plus 2i is a non-real complex number. So a complex number written in the form A plus BI is in what we call the standard form. So if we look here, the relationships over here, here's the basically the tree, okay? You have complex numbers, which are A plus BI, and A and B are real. And then non-real complex numbers where B does not equal 0, but A does, right? And then you have real numbers where B is equal to 0. And then from inside real numbers, we have irrational and rational numbers. And under rational numbers, we have integers and non-integers. And then under integers, you'd have whole numbers. And under whole numbers, you'd have, whole numbers. And then under whole numbers, you have natural. So that's today's conversation. And check out, I'm going to create another little video with EduCreations here shortly. And we'll post that. So watch the video, do the problems, learn the stuff. Have a great day.